Hello, I'm Dr. Powell. Let's look at how we can find the inverse of a number in modular arithmetic using the Euclidean algorithm. We're going to look at mod 32 arithmetic, and we're going to find the inverse of 7 bar. Now, to do this, we're going to do a little division process. 32 is equal to 7 times what plus a remainder. So we think 4 times 7 plus 4, with the remainder 4, because 4 times 7 is 28. So it's like we divided 7 into 32, got a quotient of 4 and a remainder of 4. Now we're going to repeat this process, but now this time we're going to use 7 and 4. So we use the remainder and we use the last number that we're using to divide by. So we move that up. So this will go right here. The 4 will go right here. And so then we have 7 is equal to 4 times what? It's close to 7. Well, we can use 1. And what's the remainder? 3. Now we repeat using this and this. 4, because 4 is what we divided by, right? And 1 was the quotient. So we don't use 1, but we use 4, what we divided by. So we have 4, and we put, right here, we put 3. And again, we have 1 times 3, and then we have plus 1. Whew. Actually, that's what we were looking for. If we get a 1 in the end at some point, then we know 7 bar will have an inverse in mod 32 arithmetic. Now, how do we find that inverse? We reverse engineer what we just wrote out right here in the following way. Let's take the top line. I'm going to rewrite it, this time with bars in 32 bar arithmetic. Notice that 32 is 0 in this arithmetic. So we can just subtract over one of these. Maybe let's do this one. Subtract that one over. And so we get negative, which we could actually put under one of the bars, times 7 bar is equal to 4 bar. Okay, so what we've just done is we've found out 7 times something is smaller than 7 itself and getting closer to 1 bar. So we're getting closer, negative 4 bar. So now we got to figure out how to work with the next line to help us even more. Notice what we did in the first line is we thought of the 32 as 0. So that enabled us to have 7 times something is something else. But we just, in this particular example, we just took this and put this on the other side. And then we get a negative coming out on that part. But no matter what you do, you get negative, or you get something times 7 bar is equal to something else, which is smaller than 7 in terms of representatives. So now we go down and we look at the next line. The next line will be 7 bar is equal to 1 bar times 4 bar plus 3 bar. And what we're going to do, you notice how we solved for 4 bar here? We solved for the remainder. Hey, now that was important actually, because when we solve for the remainder, look, it's sitting right here, which means we can actually replace this 4 bar with this multiplication that we just had. So actually 7 bar is going to be appearing down here. Again, it appears here, but it's going to appear here as well. And we'll see how that's useful. Because if we put this in for that, let's see, negative 4 bar times 7 bar, replacing 4 bar with it. times 1 bar, and that actually does nothing, it's just the same thing, plus 3 bar is equal to 7 bar. Let's solve for the remainder again, just like we did before. In fact, that'll be useful because you see the 7 bar and the 7 bar, we'll be able to factor it out. Then we have 7 times something else is 3 bar, which is even smaller than what we had 4 bar. So we're doing good. We're getting closer to 1 bar. So let's see that. So we need to subtract this over, but that minus will become a plus on the other side, because remember, things can pass freely in and out of the bar as long as it's addition, subtraction, or multiplication. And so we end up getting 7 bar plus 4 bar times 7 bar is equal to 3 bar. Notice that we can think of this as 1 7 bar and 4 7 bars, so it's 5 7 bars. Same thing as factoring out a 7 bar and having 1 plus 4. Anyway, so we're going to have 5 bar times 7 bar is equal to 3 bar. Okay, we're doing pretty good. Next up, we're gonna use this idea that we solved for 3 bar, we solved the remainder here, and put it in right there into the next line. So we're gonna have 4 bar, but thinking of the next line in terms of bars, all working mod 32. So 4 bar is equal to 1 bar, then replace this 3 with 5 times 7. 5 bar times 7 bar plus 1 bar. Oh, but you know what? We're going to have to replace this 4 bar with something right here. We should also replace this 4 bar with a multiple of 7 bar. So everything becomes a multiple of 7 bar except for the remainder. So not only do we need to replace this, but we want to make sure that when we make a replacement, that everything that happens is still a multiple of 7 bar. So in this case, we're going to have to replace this as well. And we can, because notice where it came from. It came from here and here. And on that line, we actually solved for it. So we have something to replace it with. And that'll always be the case. We just need to make sure that whenever we have something, we replace it with a multiple of 7 bar except for the remainder, because then we solve for it, and then that'll become a multiple of 7 bar, and we can keep going on the process. Except this is actually the end of the process in this particular case. So 4 bar is negative 4 bar times 7 bar. And so what we did is we replaced 4 bar with this, using this right here. And then we can subtract this over. Set that equal to 1 bar on that side. And see right here, we can factor out a 7 bar. And we're going to have negative 4 bar minus 1 times 5 bar. So it's just 5, right? So it's like negative 4, negative 5. So that's negative 9 bar right there. Ooh, that's the inverse. Oops. So right here we have negative 9 bar times 7 bar is equal to 1 bar. And so we've been successful at finding the inverse of 7 bar in mod 32 arithmetic using the Euclidean algorithm. Now remember, I can always go back over this again with you. Just click replay.